Welcome to the first year periodic properties of the element chapter. We have periodic properties, classification and properties of the elements which vary periodically. In that one we will consider some questions, some typical questions which we can say, which have appeared and expected to appear in the various competitive examinations. So the first question is general electronic configuration of lanthanizer. Remember, lanthanides and actinides, they belong to F block. We classify the elements as S block, P block, D block and F block. So they are also named as the F block elements are also named as the inner transition elements, because the electrons are actually entering into inner to the inner, that is anti-penultimate orbitals, that is F orbitals. That's why the configuration is N-2 F, N-1 D and Ns. Among this, since F orbital can have the maximum number of 14 electrons, that's why the correct configuration will be N-2 F 1 to 14, and there may be no or one electron in the D orbital and 2 electrons in the S orbital. That's why the correct option for this one is A. Right here, the correct option is A. When we consider this second question, in the periodic table, on moving from left to right across the period, the metallic character of elements. We know that the extreme left of the periodic table contains the metals. When we move from left to right, after the D block elements, we get the elements belonging to P block. So those P block elements, most of the P block elements are non-metals. That's why the metallic character in the periodic table across the period is actually decreasing. That's why the correct option for this one is also A. Now let us go for these the other options in the first two questions. If you take this second option in the first question, N-2 F 10 to 14, this is wrong. That's why this option B is wrong. And in case of this one, N-2 F 0 to 14, it's okay. But N-1 D 10 is wrong. That's why B, C is wrong. N-2 D is wrong itself, because this N-2 F orbitals and N-1 D orbitals, we have to write in the same order. N-2 F orbitals will contain the electrons. That's why option B, C and D are wrong. Similarly, when we consider the second question, in the periodic table, on moving from left to right across the period, the metallic character of the elements decreases. But if you consider this increase, in metallic character actually does not increase, because we move from metals to metalloids to the non-metals. And remains same is also wrong. Increases and then decreases is also wrong, because on the extreme right we have the non-metals. On the extreme left we have the metals. So metallic character gradually decreases. Coming to the third question. Atoms with high value of first ionization enthalpy which should be responsible for the high ionization enthalpy of the elements. That is the question. Now if you look into the first one, large atomic radius. If you consider the larger atomic radius, as the radius increases, automatically ionization energy will decrease. That's why the correct option will be B. As the radius decreases, small atomic radius, the element will be having the higher ionization enthalpy. Coming to the next one, loosely bound valence electrons. When the valence electrons are loosely bound, they will take less energy for the removal of them. That's why A, C and D are not correct. That's why B is correct. The element with nomenclature unanium has atomic number of. So this is the IUPAC nomenclature of the elements having atomic numbers more than 100. Here Un stands for 1. Nil stands for 0. Only, and 9 stands for N, ENN. That's why if this atomic number is 109, then we have to name this as unnilenium. If it is 101, it is unnilenium. 111, it is unnium. And 110, unnilenium. That's why the correct answer for this one is C. The next question, the radii of isoelectronic ions F minus, O2 minus, Al3 plus and Mg2 plus are. What is the correct order? Here you remember, in case of the isoelectronic species, as the nuclear charge increases, the attraction between the outer electron and the nucleus increases. That's why the radius decreases. In other words, we can say, larger the nuclear charge, lesser will be the radius. If you look into these four, F minus, O2 minus, Al3 plus and Mg2 plus. For fluorine, nuclear charge is 9. For oxygen, nuclear charge is 8. For aluminium, it is 13. For magnesium, it is 12. So we can predict aluminium having a higher nuclear charge must have the smaller radius. That's why the correct option will be Al plus 3. It is actually radii. It is O2 minus having 8 must have the larger size as compared to F minus, as compared to Mg2 plus, as compared to Al plus 3. That's why the correct option will be C. Since aluminium has got the larger radius, so larger nuclear charge, it must have the smaller radius. Compared to that one, magnesium is having little lower nuclear charge. That's why the radius of this magnesium is larger as compared to Al plus 3. Similarly, F minus having nuclear charge 9. Oxygen 8. That's why the correct option will be C. Then coming to the sixth question. The correct order of first ionization energy. IE stands for ionization energy. So among these potassium, sodium, lithium. Potassium, sodium and lithium. We move down across the down the group from lithium to sodium to potassium. As lithium has smaller size as compared to sodium, and sodium is having smaller size than potassium, so the first ionization energy should decrease. That is, potassium is having lower ionization energy than sodium, that's why, than lithium. That's why the first answer is not correct. Beryllium, magnesium and calcium. So to consider this explanation, when you take this beryllium, magnesium and calcium, they belong to same group. The outer electronic configuration is NS2. But as we move down from beryllium to, beryllium is having 2s2, magnesium is having 3s2, calcium is having 4s2. So, since this number of orbits increases from beryllium to calcium, the radius increases, that's why ionization energy decreases. But among these three, beryllium is having largest first ionization energy as compared to magnesium, as compared to calcium. That's why the correct option for this one is B. When you take this boron, carbon, nitrogen, I will write this lithium, sodium, potassium. Lithium 2s1, sodium 3s1, potassium 4s1. As the size increases, that ionization energy should decrease. So lithium is having highest ionization energy, potassium is having lowest. Then coming to this third option, BCN, boron is having actually 2s2, 2p1. Carbon is having 2s2, 2p2. Nitrogen is having 2s2, 2p3. Since this is having the half-filled configuration, it must have the highest ionization energy. Compared to that one, Carbon is having lower ionization energy because it is having only atomic number, nuclear charge 6, 2s2, 2p2. But comparing to this one, only one electron is present in the boron, it is having the lower. So boron is having, boron is having higher ionization energy than the carbon, but carbon is having lower ionization energy than the nitrogen. That should be the correct answer. But C is not correct. In case of the germanium, silicon and carbon, as we move down the group from carbon to silicon to germanium, there should be increase in the size, ionization energy decreases. So carbon is having higher than silicon than germanium. That's why A, C, D are not correct, only B is correct. The next one, which of the following equations represent electron affinity? Electron affinity is nothing but electron gain enthalpy, which is indicated with the sign of the enthalpy. So according to definition of the electron gain enthalpy or electron affinity, the energy either released or absorbed when one electron is added to an isolated gaseous atom. So when we consider this atom X, you should take this in the isolated gaseous state. When an electron is added to give rise to a uni-negative ion in the gaseous state. For such a process, the energy change is named as the electron affinity or electron gain enthalpy. So this equation is indicated in the option D. So this D option contains X gaseous plus electron giving rise to X minus. So for this answer is D. The next one, while moving from lithium to fluorine in the third period, there is a decrease in which of these properties will have the gradual decrease in the values. So when we move from lithium to fluorine, lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine, we know that the electrons are added to the same orbit. The nuclear charge will increase. Electrons are added to the same orbit. That's why gradually there is a decrease in the atomic radius. So the correct option for this one is D. Ionization energy actually varies depending on the other factors also. There is no regular decrease or increase. Sometimes it increases, sometimes it decreases. In case of the electronegativity, there is a continuous increase. Electron affinity, again there is a gradual variation or irregular variation, we can say. Only there is a continuous decrease in the radius when we move from lithium to fluorine in the third period. Here you remember, the next element is not taken, that is neon is not taken, because for the neon there is a radius called as the covalent radius, van der Waals radius. Only for these we consider the covalent radius. The next one, the correct order of second ionization energy of. So when we consider the second ionization energy, first we have to consider the electronic configuration of the various elements. For the carbon, I will write this as 1s2, 2s2, 2p2. For nitrogen, we write 2s2, 2p3. For oxygen, 2s2, 2p4. For fluorine, 2s2, 2p5. When one electron is lost in all of these, to give rise to the first ionization energy. So this is first ionization energy. When the configuration for this C plus will become 1s2, 2s2, 2p1. For this one it will become 2s2, 2p2. For this one it becomes 2s2, 2p3. For this 2s2, 2p4. Now for this loss of the second electron, just observe the configuration. This configuration for the oxygen with one positive charge will be having 3 electrons in the p orbital. That's why this is the stable configuration. That's why this requires the highest second ionization energy. When we consider this oxygen as the highest, then comes nuclear charge increasing in case of the fluorine, that's why it is fluorine. Then comes oxygen, fluorine, and then comes nitrogen, and then comes the carbon. So second ionization energy will be highest for oxygen and lowest for the carbon, because once the electron is lost, the stable configuration will be for this oxygen. So the correct answer will be C. Atomic number of an element is 33. It belongs to which group? When we write the electronic configuration 33, for the atomic number 33, we have to write 1s2, 2s2, 2p3, 2p6, 3s2, 3p6, and then comes 4s2, 3d. Here up to this it is 10, this is another 10. Similarly, 3d10, it is 30. Then comes 4s2, 4p3. Up to this one it is 30. 10 plus 10 plus 10, 4p3. 4p3 configuration is actually for the nitrogen family. For the nitrogen family, the group number is actually 15. It is actually 13, 14, 15. So the correct option will be 15. So these are some of the questions. In the next video, we will consider some more questions and then go for the next chapter. Thank you.